Hey guys, this is Alan with Bothell STEM Coach, and today we are going to start the AP Calculus AB 2012 free response questions. So let's take a look at some of these here. As a reminder, the first two questions are graphing calculator questions, so I have the GeoGebra calculator here for us to use. So the temperature of water in a tub at time t is modeled strictly increasing twice differentiable function w, where w is measured in degrees Fahrenheit and t is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees. The water is heated for 30 minutes beginning at time t equals 0. Values of w, t are selected. Use the table to estimate the derivative of w with respect to 12. So because we just have data points and not exact value, the slope or the derivative of 12 can be done by estimating the secant line slope between 9 and 15, because 12 lies between, t equals 12 here, lies between 9 and 15. So the secant line slope is approximately equal to 67.9 minus 61.8 divided by 15 minus 9. Minus 61.8 divided by 6. So that's 1.017. And the units here are, this is degrees Fahrenheit per minutes. Degrees F per minute. Okay. Use the data in the table to evaluate this. Using correct units, interpret the meaning of this in the context of the problem. Okay, so we're going to do the air. Okay, so the area under the derivative, what I do is I do the antiderivative of this and then plug in by fundamental theorem of calculus. This is w of 20 minus w of 0. And that is equal to 71.0 minus 55. And that's equal to 71 minus 55.0. And that's, what, 16? The units are this degrees F. And this is the temperature of the water increased by 16 degrees F over 20 minutes, or over the 20 minutes, the water and the temperature increased by 16 degrees. That's what it would be, the change from the temperature from 0 minutes to 20 minutes. Okay. For 0 less than equal to t and less than equal to 20, the average temperature of the water is this. Use the left Riemann sum with the 4 subintervals indicated by the data to approximate this. Does the approximation overestimate or underestimate the average temperature of the water of these 20 minutes? Explain your reasoning. Okay. So we'll do this down here. So 4 subintervals means this is going to be one subinterval, this, and this. Those are the 4 subintervals. And I'm using a left Riemann sum, which I'm always going to use the left value for. Okay, so this subinterval has a width of 4. And the height, remember, you kind of think of it as rectangles, right? The width of this rectangle 4. The height of this rectangle is the left point, which is times 55. Plus, this width of this interval is 5. Times the height of this rectangle, against the left point, 57.1, plus the width of this interval is 6, times the left point being this one, 61.8, plus the width of this interval, which is 5, times the left subinterval height, which is 67.9. Okay? So 4 times 55 plus 5 times 57.1 plus 6 times 61.8 plus 5 times 67.9. Now I got to divide all of this by 20, right? That was what they wanted. Oops. Dividing it by 20. $60.79. Now, what are the units of this? Well, I integrated over this whole region. So that's sort of like degrees Fahrenheit minutes. But then I divided by 20 minutes, the width of this interval. So it's just degrees Fahrenheit. This is the average. This is average value. This is the average temperature of the water. Okay, so it's the average temperature of the water over the whole 20 minutes. Now, is this an over and under estimate? Because it's increasing. Well, is it increasing? Let's see. The gap. Let me think. Let's see. An increasing function. It's an underestimate because the temperature is increasing. So like when I use this left subinterval, like I'm always like grabbing the smaller. See, like when I pick the left or the right, I pick the smaller value, and that's because so this is an underestimate. Underestimate. And it's an underestimate for the specific reason that the temperature is increasing. When it's increasing, my left subintervals are always like, it's when it's decreasing is when the left subinterval is kind of like an overestimate. Like the area under the rectangles would be bigger. Okay, so for 20 to 25, the function that models the water temperature is first derivative given by this. Based on the model, what is the temperature of the water at times t equals 25? Okay, so I got to see like how this is the rate of change that the water is, and if I want the water at 25, I have to integrate from what, 20 to 25, because that's what I want to go up to 25, w prime of t dt. Okay, and I want to add to it whatever, and this is just the change of the temperature between 20 and 25. This started out at 71. Right, this is W of 20 here. So it starts at W of 20, whatever temperature that is, and then this is what it changed between 20 and 25. So I want to integrate this one here. So I want to do the integral of 0.4 square root of x cosine 0.06x. And I want to integrate that from 20 to 25. And then I want to add to it 71. And I got 73.043. Now I just want to make sure some settings here. Am I in... I don't know, how do I know what trig mode I'm in? I'm going to assume I'm in radians, even though like I should probably check that if I were really precise. Let's see, global settings, basic color, algebra, scripting. This is like visual stuff. Oh, unit angle, radians. Okay, so let's do that one again. Okay, I guess it must assume that it's already in degrees when it does those things. So, or sorry, it already assumes radians. And that's that. Okay, so let's look at the solutions. That'll tell us the answers anyway. Okay, let's kind of make this bigger. 1.017 or 1.016, and that is what I got there. 16, the water has warmed 16 degrees. That's right. 60.79, the approximate is an underestimate because the left number is used and the function is strictly increasing. And then 73.043. So hope you guys found that helpful. Yeah, I'll see you guys in the next video when we continue on with the free response questions. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.